Dr. J. Kamala received her BE in Electronics and Communication Engineering from Madurai Kamaraj University in 1989, ME in VLSI Design from Bharatdasan University in 2002, and PhD from Anna University in 2011. She is currently working as Associate Professor in the Department of Electronics and Communication Engineering, Anna University, Chennai. Her research interest includes VLSI design, solar power, controller design, and smart sensors. She has published several papers at national and international journals.
Welcome to the UGC lecture series on agriculture engineering. Today we are going to see about renewable energy part. In this part we are going to see about solar lattern, solar street light and solar fencing application. First we see about solar lattern. Solar lattern is an emergency light used in standalone power failure conditions. During night time, if there is no power from the electrical grid, and we can get light energy using this solar lattern. So, it is a lighting module consisting of three components. One is PV module, another one is battery and another one lamp. These three constitutes the solar lantern. Here first we see about solar panels required for the solar lantern. The solar lantern lighting is for very small area, so higher power wattage panels are not required. It is enough to have lower range of solar panels. The solar panels can be of two types. Either we can choose this type of solar panel, the top one, or we can choose the bottom type of solar panels. If we choose the top solar panels, it is smaller in size and light in weight and thickness is also very small. So, we can attach these top solar panels on the top of the solar lantern. If we use the solar panels in the bottom side, a separate panel is to be attached with the solar lantern. It cannot be attached. So, if we see the different types of panels, we are having two types. One is polysilicon solar panels and another one is mono. Mostly we are using polysilicon solar panels. The ranges from 0.6 watt to 10 watt or 15 watt. 0.6 watt and 5 volt, these are the, and 0.12 amps polysilicon panel. The size of these panels, the top solar panels in the figure is having minimum thickness, it is around 3 millimeter. So, we can choose 1.3 watt, 1.9 watt, 2 watt panels. These panels can be attached on the top of the solar lantern. If we choose the bottom solar panels, it is having a thickness of 18 mm or 15 mm. They are enclosed in a glass envelope. They are robust and strong. In case of the top solar panels, they are not that much strong, but anyway it is attached on the top of the solar lantern. So, safety issues will not be a problem for the top also. If we choose mono crystalline silicon panels, here also we are having wide range of panels, 6 watt, 6 volt 1 amp panel, 6 watt, 12 volt, 0.5 amps panel, 10 watt, 17.56 and 0.5 amps panel. According to the battery capacity, we can choose the panel and how much time we want to light the solar lantern. Accordingly, we can choose the solar panels. Next one is rechargeable batteries. The rechargeable batteries, here also we are having different types of batteries. If we want to use portable, smaller in size, light in weight, we can use these type of solar rechargeable batteries. If we want the portability is not a problem, and the solar lantern is to be fixed at a point and it is not to be carried away. Size is not a problem means we can choose this type of batteries. Here also choosing the batteries decide the working hours of the solar lattern. If we want the solar lattern to be working for a longer period of time, we have to choose higher capacity battery. If we want lesser time to be lightened, the solar lantern is to be switched on for a very less time means we can choose smaller capacity battery. And the different batteries, if we see, the voltage and current capacity decides the battery operating range. The major types of batteries 1.2 volt nickel cadmium batteries with different current ratings. If the current rating is very high means it will operate for a longer time. Next one is 1.2 volt nickel metal hydride battery. This is also with 1.2 volt. Current ranges from 300 milliamps to even 4 amps or 10 amps. That depends on the cost and the charging time, discharging time, of life, operating period, everything. Next one is 3.2 volt lithium iron phosphate battery. Another one is 3.7 volt lithium ion battery. These batteries are smaller in size, light in weight and it works for a long time. Portability we will get for these batteries. Another one is lithium nickel manganese cobalt battery. It is also available. Next one is sealed lead acid battery. That black color batteries are sealed lead acid batteries. It is also available in various ranges from 6 volt up to 24 volt, 48 volt. We can have different batteries, but for solar lattern applications we always choose batteries of lower capacity. Sealed lead acid battery 6 volt 4.5 amps. These are the different types of batteries we can choose for the solar lattern. Another one is 12 volt 7.2 ampere hour sealed maintenance free value ranged lead acid battery. These are the different batteries we can choose for solar lattern. Next, light emitting diodes. Light emitting diodes we can have different types and in different colors. If we see the operating voltage of the LED light emitting diodes ranges from 1.7 to 3.6. For different voltages and different types of junctions we have different colors. For example, red at 1.7, orange at 2.1, yellow at 2.3 volt, green at 2.3 volt, blue at 3.3 volt and white at 3.6 volt. Approximate voltages applied to get color light from the LEDs. These color LEDs are used in traffic lighting system and in grow LEDs, and these LEDs consume very less power. It draws very less current and voltage across the LEDs also very less. So, power dissipation of these LEDs are very small. Other type of LEDs are power LEDs. It may be available in strip form or it is available in single form also, that can be arranged in a circular form to form a light. These power LEDs are actually used for lighting application because it provides high beam, white light or blue light. The advantages of these light emitting diodes are it is having high efficiency, more than 60 lumens per watt, and long operating life compared to other CFL lamp and other conventional lamps. It is having more lifetime, around approximately 50,000 hours, and low voltage operation from 1.8 to 3.3 volt approximately. So, most of the applications today use LEDs for lighting application, and we are having different power consumptions also. 1.5 watt LED, 3.2 watt, 5 watt LED, according to the illuminance we want in the area, we can use different types of LEDs. And this is LED, if you see, it is a light emitting diode. The construction, if you see, it is having a P type material and N type material, they are joined together. When it is forward biased, the energy level of free electrons in the conduction band will be greater than energy level of valence electrons or holes in the valence band. Because of this, the electrons and holes break away from the bonds. When it is breaking away and entering into the lower energy level, the photons are emitted, that is, light is emitted from the LED, and we can identify the terminals plus anode and negative cathode. If we see the glass terminal, we can see the flat terminal inside the LED. The LED is encapsulated in a glass envelope. So, we can see the terminals inside the glass envelope. The flat terminal is cathode and a thin terminal is anode. The symbol for the LED is represented like this. This arrows represents emission of light from the LED, and we can have different types of LEDs and for different applications. For traffic light application, we color LEDs, and for lighting applications we use power LEDs. This is the operation of light emitting diode. The top LED symbol is power LED and it is used for lighting application. In these LEDs, the positive and negative terminals are identified by symbols represented. Here it is represented positive, on the other side the symbol is represented negative. So, we can easily identify the symbols of the LEDs. And next, so solar lattern consists of solar panel, then rechargeable battery, and it may be of any type, lead acid battery, lithium ion battery or nickel cadmium battery, and we will be having lamp using LED. So, these three components are connected through charge controller. The charge controller will be taking care of charging the battery from the solar panel. From the solar panel, the voltage and current are passed to rechargeable battery. According to the battery specifications, it will connect the battery to either to solar panel or LED. And here also charge controller, according to the battery status, it will connect the LED and the LED will be lighted by the battery. These are the basic operations, that is just lighting. Charging the battery and lighting the application are the basics of solar lattern, but nowadays we are having solar lattern with USB charging options for battery cell phone charging. Other options we can include in the charge controller. Similarly, instead of illuminating the LED at one particular level, we can have different ranges. For example, we can have dimmer control. The intensity of the light from the LED can be controlled. It can be minimized or maximized or intermediate level. So, advanced options can be easily implemented in the charge controller. Next application is solar street lighting. So, it is a significant cost saving method and it avoids lay down of electrical wires, distribution points, labor charges and digging hassles. because some of the remote areas are not accessible for the electrical grid. In that case, this solar street lighting is the efficient or optimum solution. The advantages, if we see, if we use LEDs, it is having high lifetime, for example more than 10 years the lifetime of LED lighting compared to conventional CFL or incandescent lamp, where the lamps are to be replaced at least once in a year. Here it is not necessary if we use LEDs. Then easy installation, zero electricity cost. The lights are powered by solar panel, so electricity cost is zero, only initial investment is required, and it is environmental friendly and easy disposal because there is no harmful substances like mercury and lead and less heat is generated. So, it is environmental friendly, and we can have higher color temperature of light, that is pure form of light. Carbon credits and subsidies may be availed for larger number of installations. These are the advantages of solar street lighting. The solar panels, if you look for the solar street lighting application, we normally use solar panels of higher capacity. Solar lattern is used for illuminating a small area. Solar street lighting is to illuminate larger area or a street. So, we used solar panels of different sizes. For example, the range starts from 16 watt, 20 watt, 30 watt, 40 watt and 110 watt, 60 watt and 50 watt. So, these are the different solar panels we use for solar street lighting application. Here each cell, if we see the 16 watt panel or 36 cell solar panel, we can see number of panels are connected in series. Each cell produces 0.5 volt per cell and the cells are connected in series. So, if we have 32 or 36 cells connected in series means we get 18.5 volt to 20.8 voltage peak from the solar cell. From 64 or 72 cells we get 24 volt, and for 96 cell solar panel we get around 48, nearer to 48 volt panels. So, this is the 36 cell solar panel. In each row we are having 9 cells are there, and positive of one cell is connected to negative of another cell. Like that all are connected in series. Like this we can have 64 or 72 cells or 96 cell solar panels. According to the lighting application, if we want to illuminate very large area or we need high beam light means we will go for high power solar panels. Next one is street lights. Street lights, we have chosen the LED street lights because we are having more advantages of LED street lights. If you see, if the solar panel is range is small, for example 16 watt or 20 watt, the size of the solar panel will be very less. Back side of the light we can have the solar panel. In the front side, that is the side towards the street, will be the LEDs are placed in that one. The back side we will be having solar panel. If the solar panel size is very large, in that case solar panel is attached separately. The amount of light emitted from this or corresponding solar panel required for the light is given here. For example, if we install 18 watt solar panel, we get a illumination of 468 to 1197 meters. The illumination for this range we will get, luminance we get. For 36 watt we get 936 to 2394 luminance. 28 to 112 watt means we get 2100 to 8400 luminance. So, if we increase the wattage we will get higher luminance. So, if we compare this LED with the incandescent lamp, A 280 kilowatt hour LED is equivalent to 320 kilowatt CFL lamp and 1500 kilowatt hour incandescent lamp. So, LED is more efficient than the other types of lamps, conventional lamps. And next one is solar street light batteries. The batteries decide how the operating period, how long you want to light the LEDs. If we choose very lower capacity, for example 7.5 amps and 12 volt means the operating period will be less. If we choose 100 ampere hour battery, the operating period will be larger. Number of hours, whether you want 3 to 4 hours or 8 to 10 hours. If you want for more number of hours, we have to choose battery of higher capacity. If we choose lithium ion battery, we can allot some space in the solar LED light. Here solar panel, here we are having battery, and the back side we will be having LED lighting. So, everything can be placed inside it. If our battery specification is very high, then the battery is to be placed separately. So, these are the different types of solar street lights. Here the battery is placed here, solar panel and light. We can have, if the battery is very heavy and large in size means, instead of placing it in the middle, we can choose at the bottom also. So, these are the different types of solar street lights. When we are install the solar street light, the panels are to be placed towards the sun, and we have to choose best day lighting location, and we have to avoid places such that shadow of houses and trees should not be there, because it avoids the sun rays and the output power will be reduced. So, that is the location specific requirement of solar street light. And the surface are to be of the solar panel are to be cleaned frequently to remove the dust, dirt, everything, because it will reduce the solar power output. To protect from the rain, it has to be waterproof the design, otherwise the rainwater enters the circuit and spoil the all circuits in the controller. Then metal parts of the solar street light should be made of corrosion resistant aluminum or stainless steel, because it is exposed to all environmental conditions. And solar controller is the more core component of the solar street light. There we can add different types of controllers like dimming, timing, automatic on off, charging and discharging of batteries, all are implemented in the solar controllers. Next, another application of LEDs are grow light. The LED grow light is used for indoor crop growing application, where lighting is not available for most of the period. In India, it is not necessary. If we want to protect our crop from environmental hazards, we can go for this method, or we are going for vertical farming, or we want to produce large amount of food in smaller area, then we can go for this method. So, all environmental degradations can be avoided by using LED grow lights. If you see the lighting requirement for the plant, the photosynthesis is activated in the 400 to 700 nanometer range. In this 400 to 490 meter is the blue light. It is used for mainly vegetation purpose, and 580 to 700 nanometer corresponds to orange red light, is used for flowering and fruiting phase of the plant. So, this is another recent application of LEDs in the agriculture. And the purple pink is the combination of red and blue wavelength that can be used, and it is from the seeding up to the growth it can be used widely. Next one is solar fencing. Solar fencing is used to prevent wild animals, particularly elephants, to entering our field and destroy the crop. So we can use solar fencing, and it provides a psychological and physical barrier for the wild animals. Any kind of intrusion will produce audio alarm and in the vicinity of more than 350 meters within 2 seconds. It produces a high voltage that produces an energy of about 3.5 joules, and it will deter the active element or physical barrier for the wild animals, and it is a reliable protection system for villagers. So solar fencing, if we see, we will be having a solar panel and related control circuit and fencing for the field. So it is a fence powered by solar energy with a backup by battery. Even it will work in the night and cloudy days. The voltage sent through the wire is so high and the current is very low, so it will not be harmful to the animals. It will create a very short shock, so that the animals will be stay away from the field. The high voltage is around 8000 volt and the current is around 120 milliamps. So it will have a solar panel, battery, energizer and a fencing. From the solar panel, the power is delivered to battery. From the battery, energizer uses it and the current is applied to fencing circuit, and it does not need a complete loop to provide the shock. It will send a current to the electric fence about once in a second and again back to electric fence charger and complete the circuit. Then it removes the current. So it is not harmful and it is shocking for a very short period, and the wild animals will stay away from the field because of the electric fence. And the protection we have to take for this one is, if we want backup period of longer period, means we can choose 12 volt 90 ampere hour battery and solar panel of 12 volt 74 watt peak solar PV panel. In addition with this, we can have protection circuits like lightning diverter, because during rain there will be some loss in the voltage and the high voltage is to be blocked by a choke. So we should have separate earthing system for the solar fence and the lightning circuit, and all the circuits and battery are to be placed in a safer place such that it is not damaged by rain, storm or other environmental hazards. So the protections are to be taken carefully in the solar fencing process. So with this we have seen solar lattern, solar street light and solar fencing in the agricultural engineering. Thank you.